In this video, we are looking at how to do quality management tools in Python. And here we're looking at a histogram. So if you're working along with us, then go to drsteppowers.github.io/mgmt-in-python. Once you are there, we will go down to the quality management tools and we're working on histograms. Click here. This will take you to the GitHub site. And at the top of the GitHub page, you'll see an Open in Collab button. Click on this button. That allows you to access the worksheet. In order to run the code and amend the code, you need to sign in to your Google account here and then make a copy to your drive. The other thing to remember is if you want to capture your own changes, then you need to make sure that you save your work. So unlike a lot of Google documents, the Google Collab requires you to save your work. It doesn't auto-save. All right, so we are now in here in our quality management workbook here, and we want to create a histogram. So a histogram looks at the number of, the frequency of events. And so here, for example, this is a part retrieval at our warehouse. And so we can see on the bottom of the graph how long it takes for them to retrieve parts. And then on the vertical axis, it's the frequency. So we can see that here, that almost 40 of the retrievals took between 3 and 4 minutes. Okay, so when we look at a histogram, we want to know if there are any extremes. So did the retrieval times take a long time or a very short time in any of the cases? Or do they generally tend to kind of lump together? And so we want to look at the range of values. Here, retrieval at the warehouse ranges from 1 minute to 12 minutes. And we can see that the distribution here is bimodal, meaning we have 2 bumps. And so there are retrievals here that congregate around that 3-4 minutes. And then there are retrievals that congregate here around about 8 minutes. So when we look at this quality tool, this leads us to ask questions. Why some of the time does retrieval only take 3-4 minutes? And why does retrieval sometimes take 8-9 minutes? Maybe these are different shifts. And so maybe something different is happening between the morning shift and the evening shift. Maybe it's orders that are stored in one location versus orders stored in another. And so we would look at why is it happening that we have some orders that take 3-4 minutes and why some take 8-9 minutes. To create a histogram in Python, we're going to need to import matplotlib.pyplot as PLT. And I'm just going to switch over to the version where I'm logged in and I've saved a copy to my account. So I'm going to import this so I can do some graphing. And throughout our Python videos, anytime we are going to do any math, we need to import pandas as PD. Anytime we're manipulating our data, we're often importing NumPy. So it's a good habit really just to kind of install those 3. Rarely do you not need them. Sometimes they conflict with other packages, but for the most part, just having all of them installed is a good way to start. All right, so let's suppose we want to build a histogram for complaints at our organization. So in 1 week, we get 4 complaints, and the next week we get 10 complaints. So we want to know generally how many complaints we're getting each week, so we can kind of see what's the range, what's the most common, and start to explore the data even further. So we're going to enter our information in, so complaints equals, and then we'll just put it into hard brackets here. And we have our different complaints by week. So week 1 is 4, week 2 is 10, week 3 is 14, week 5 is 8. If you have multiple branches, these could be complaints at different locations as well. So we're looking here, as we plot it, we want to plot the complaints. Now, when you build a histogram, like we saw in our picture here, we need to decide on the bins. That is, what different amounts are you lumping together? And so here it was lumped together essentially in 1 minute increments. And in this here for our complaints, we could decide, for example, to lump it into 2s. So how many bins do you want? Well, you don't want too many bins that when you graph your data, you can't see any clumping, right? So we want to see what the most common is. If we just had 2 bins, 0, 5, and 5, 10, then it would put all the data into like 2 columns and we really couldn't see anything either. So you want to play around a bit to make sure that you have enough bins, but not too many, in order to see the information. So for example, here we're going to use plt.hist. We're going to plot the complaints. Let's use our bins here in increments of 2. So we'll have 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, 10 to 12. And just to make things easier to see, we'll put an edge color around the rectangles so that we can clearly see the separation. So edge color was black. We'll label the x-axis, that's the horizontal, that's going to be the number of complaints. And our y label is going to be the number of samples. If this is the weekly reports, then this would be number of weeks, right? So we would then run that. Oh, I must be in the wrong one again. Hang on. Click on the right one. All right, complaints, and plot that. All right, so we can see here that we have a lot of complaints each week. That 4 to 8 complaints is very common, but we have the most common is that we have 10 to 12 complaints in a week. So notice there's 4 weeks where we had 10 to 12 complaints. So we're skewed a bit to the higher end. We have an issue here with lots of complaints happening in our business. Now notice if we change this, so instead of in 2 increments, let's say we put this, let's change this here and let's do 0, 4, 8, 12. Okay, and if I run this again, you can see now I've very limited the bins. It's much harder to see any kind of relationship. So you want to make sure you have enough bins. And the other thing is you don't necessarily want it to be, let's see, 6, 7, 8, 9, 10, 11, 12. So if you did something like this, where it's just every number, then you just start to get this flat line here, and this is not as helpful. We want to look for modal distribution. We want to look for, like you could see here, where is it congregating. So that helps you as you're looking for what's the appropriate number of bins, right? Having it just be 1 is too many bins, and then having it 0 to 4, 4 to 8, 8 to 12 was too little. So you got to find the number in between, and also ask yourself, what is it we're able to actually work with given this information? So if I go back to my 2, 4, 6, 8, 10, 12, then we can see this information here. Now the other thing to remember is that this data here goes beyond 12, and so you always want to have more bins than you have in terms of your data. When you do histograms in Excel, for example, the built-in histogram in Excel always does a more than and puts everything at the end. That's not built into Python, so you'll need to make sure that you have covered all of the data when you type in those bins if you're specifying bins.